So we're coming to the end of our transformations. This is the last transformation we're going to look at, and it's called dilations. So a dilation is just going to be a stretch or a shrink. So let's take a look at the transformation rule. So the transformation rule here is going to go from x, y to kx, ky. So where k is the scale factor, that's how much the shape is going to enlarge or it's going to get smaller. So let's take a look here. We're going to dilate the rectangle EFGH by a scale factor of 1/2 about the origin. So just like we had rotations about the origin or another point, you can do the same thing with dilations. So essentially what's going to happen is I'm going to take each x and y and multiply them by 0.5 or just basically divide by 2. So I'm just going to come over here and I'm just going to list out the points for E, F, G, and H, the image of those. So all I did was take the x value, multiply it by my scale factor, which was 1/2. Again, that's the same thing as dividing by 2. So our shape is going to be smaller. So my scale factor is between 0 and 1. So if it's a fraction, then you're going to have a smaller shape. And if it's larger than 1, then it's going to be a bigger shape. So, and that's another way to kind of sort of double check yourself. So let's just now go through and plot all these points. And there we go. So that is our new shape. So I just took the scale factor, multiplied by x and y. Can't just do one or the other. All right, so this time we're going to dilate the triangle ABC by a scale factor of 2. So this time it's going to be larger. But we're also going to do about the 0.42. So the 0.42 is right here. So what you're going to have to do is you're going to have to count, kind of like what you do with rotations. You're going to count how far over and up, and we're going to multiply the over by 2, and we're going to multiply the up by 2, and that's where my new point is going to be. So to get to A, I'm going to go down 1 and left 1. So the new scale factor is 2, so I'm actually going to go down 2, left 2 to get the new A, to get A prime. So I'm I'm dilating about the red point. So I'll make sure we note that. And then for C, this one's a little bit easier too. B is a little bit more challenging. So C is down 1, right 3. So I'm going to go down 2, right 6. And then B is right 1, up 4. So right 1, up 4. I'm going to go right 2, up 8. And then this is going to be my new triangle. So you can see that's larger. And it's about the 0.42. So remember what I did is I just went ahead and I just noted which way over, how many over and how many ups, basically. And then I just multiplied that by my scale factor. So I made the new origin at my red point and just grew it from there. So now when I name these points, I'm going to forget that I dilated about the 0.42. That doesn't matter. The overs and the ups don't matter anymore. When I go to name them, I'm just going to name them as their normal points as the regular like the regular coordinate points. So A prime is at 2, 0. B prime is at 6, 10. And then C prime is at 10, 0 as well. All right, so this time we're going to dilate by a scale factor of 1/2 about the point -3, 1. So just like it worked before, so -3, 1 is right here. So I'm going to take each distance overs and ups, and I'm going to take those and basically divide them, each of them by 2. So let's start with point X. So X is over over 4 and down 4. So I'm going to go, or right 4 and down 4. So I'm going to divide both of those by 2, which would be right 2 and down 2. So from my red point here. So this is going to be x prime there. So right 2, down 2. So y is actually up 0 and then over 10. So I'm going to take the up 0 divided by 2 is still 0. And then I'm going to take over 10 divided by 2. So I'm just going to go over 5. And there's y prime. And then z, this is a little bit more challenging. So z is over 7 and down 7. So I'm going to take both of those and divide it by 2. So I'm going to go over 3.5 and down 3.5. So it's going to be inside, pretty much smack dab in the middle of that square there is going to be z prime. So there's my new triangle. So since I have a scale factor of 1/2, I would expect it to be smaller. So if it's not smaller, then you did it wrong, especially if your scale factor is between 0 and 1. So if it's a fraction, it should be smaller. So then again, if we were just to list out these points, I know it doesn't tell you or ask you to do that. So x prime is going to be at -1, -1. Y prime is going to be at 2, 1, and then z prime is going to be at 0.5 and down and -2.5. And I know that those are 0.5. So sometimes you've heard me say, well, we don't know what that exact point is. And you're right, we don't know exactly. So I could be a little bit off just because of my human eyes, but I know that I'm supposed to go over 3.5 and down 3.5 based on the dilation and the scale factor. So dilations, this is where you're going to take the x value and the y value, and you're going to multiply them by your scale factor, even if your scale factor is a fraction. So if you take that and you multiply by that fraction, it's going to get smaller. If your fraction or if your scale factor is larger than 1, it's going to get larger. If you are going to dilate about a different point, you're not going to name that point anymore. The name of that point is lost. You're going to count the overs and the ups or overs and the downs and then apply that scale factor to the overs and the ups or downs, okay? Keep that in mind as you work through this transformation of dilations.